I think I actually counted 9. So my name is Cal Toth.
Not sure that we're sharing to Zoom.
You want to do that? Can you hear me this way?
Nobody will be able to respond. Zoom workplace. Expand that.
This is picking me up, all right?
Share. Share. I don't know which one to share. PowerPoint slideshow, that one. Or this one? Okay. Share. Yeah. Beautiful. Hold on a sec. Hi, buddy. There you go. You're set, I think. Are you going to talk in? This is the amplifier for the room, and this is the one for the. So you need to talk in the book.
I do.
Yeah.
So am I standing in the right place to talk in the both, or do I have to get over here? Okay. So yeah, easy writer generation, and really like doing karaoke. So this is a summary, okay? This is a summary of a paper I gave. It's in the proceedings of the October conference, at the last paper actually, and the proceedings. And I'm just going to give a quick kind of overview so you have a kind of an idea of it. If you find interest and you delve into it and you want to read it, just go into the proceedings or go online. And the online URL is this one, cal_toth_2024. So what this paper talks about is taking a look at the problems of identity on the internet and the problems we have with having all these damn all these passwords that we have to deal with. So we see this sort of idea of, over the many years now, impersonation breaches climbing like crazy. I have to do this to it. All right. This is going to work for me.
Make sure that's on the right thing.
This one. Or it just
should be with that. Try that.
Oh, that. Okay. So things like breaches and impersonation climbing like crazy, solution strength is climbing very slowly, and we want to try to do something about it. Is this really going to work? Okay, so the notion here is to reduce password dependency through an architecture that is agent-based. Okay, an agent-based identity architecture. So the notion here is to decentralize identity, make your identity self-sovereign. People, owners, they own and manage their own identities. They control them, and they're intuitive, easy to use, like identities in your wallet. The other dimension to it is that you proof and attest each other's identities, just like you would if you went into a bank, opened an account, and the bank manager proofs who you are. So that's part of the formula. Okay. So we know the internet has no identity layer. This approach is integrative. It uses agents, kind of like some of the agents you might be familiar with that you've used in the real world online. And we have digital identities look like identities in your wallet. So it's integrative because you know what the system handles is what the owner knows, what the owner holds, right? What the owner is, i.e. biometrics, what the owner asserts about themselves, about who I am, right? And what others proof and attest to. If I go to the bank manager, that manager is going to proof my identities and say, this is really Cal Toth. The other dimension is, well, what's this really look like? So we have a user who has a personal device that they control. They load an identity agent into that device. They use it to create digital identities, and they are controlled by the agent, by the owner, just like they're credentials in their wallet, and they minimize the use of their passwords. So that's the notion, that's what we're trying to achieve. Okay. So what are these identities used for? Not just to identify who you are, but to help you protect your and secure your information, your private information, of course, but also your identifying information and your transactions. So we have encryption keys that sign, encrypt, and what I've called seal and attest your digital identities and other digital artifacts. It also, this ability to seal and attach your identity to something, to a digital artifact, allows you to control how you consent. Rather than having the service providers do this for you, you do it with your own device. And you do things like notarize your documents by digitally signing who you are to these documents. So you do all those things. So that's the idea of this architecture, achieve those kind of goals. So if we look at the architecture, we have an owner, an identity agent, has to be trusted. You have to test the hell out of it. You want to know that it's going to work properly. We also want to be able to have it developed in the open source world, right? So we'll have just like a tool like BitTorrent, if you have used BitTorrent to download, distribute information over the internet, it does gives you a lot of ability to scale out tools to the internet. So any open source developer would want to be able to do this if they've created an identity agent. And the identity agent has to implement the protocols, right? Has to implement a common set of protocols. So we have a personal device, an identity agent in it, the owner needs to control this device in some way. So the authenticators that are provided in the hardware environment probably need to bind your authentication data and protect it. Just push it out of it. Okay, great. So this sort of illustrates the idea of up here of different types of digital identities. They look a lot like a real identity, but they have encryption keys associated with them. So these white and red encryption keys are public and private keys that are associated with your identity. So when you distribute your electronic digital identity to somebody, they don't get your private keys, they only get your public keys. And you have three of them, as we'll see. We can also use these keys to attach to your own digital identities, other folks' identities that you collaborate with, to consent tokens. This is kind of described in the paper. I'll get it sooner or later. So this capability allows these agents to talk to each other, and they can talk to each other securely. And through the cloud. They have a couple of services that they rely on, and these services could be blockchain based or some other strategy to distribute them widely. But one of those components is a proof of existence identity registry, which allows you to prove that your identity is the one that you claimed it was. So when you're distributing it, others can confirm that it actually exists, that it represents you. And there's an exchange service where if you connect with somebody that you know or you've met, maybe face to face, then that service uses Diffie-Hellman to distribute it, your identities reliably. So these things are listed here: encrypting, decrypting, sealing, proof of possession, and proof of custody. These are all parts that have to be implemented in the protocol. And I have a figure here, it's in the paper, that sort of illustrates the idea of you having a cell phone where you control your digital identities, you control the device, and it has these capabilities built into it. So this is, for example, my wallet in my phone with my digital identities. And these are digital identities of people I collaborate with.
Do you have mine in there?
Maybe,
If it's really you?
yeah, I want to make sure it's you. So I'll test that it's you. I'll attest to that, right? And that's an important part. How I do that, it's interesting. So the authenticator, other things are shown here. I've got some annotations here. I won't go into it. How digital seals are, for example, structured. And the fact that this device communicates with other devices and that these digital identities of other folks that you communicate with can't be impersonated because they don't have the private keys. I've put together a reference model to support development. It's kind of complicated, a lot of stuff, as you can see up here, but those are the functionalities that are built into the agent. And so if somebody's building in the open source community, building to this protocol, to this system, to these agents, they build an agent that implemented and supported these functionalities in whichever way they feel is reasonable. Of course, we need some good testers and software quality people to make sure the code is reliable. And the reference model also includes a specification part for the protocols to support the development. And so there's a flow chart here that sort of explains how it works. So that's my talk. I'm ready for questions. And if you're looking, and in here, you see a connection to LinkedIn, so you'll find me in there. And you'll find also I've repeated the URL that takes you to the paper.
You went 9 minutes and 32 seconds.